Hi, my name is Neven, and I'm going to show you how and why we introduced HashiCorp Vault as a secret management solution and what challenges we encountered. But before that, I need to ask something from you. So I promised some people that they will see me on this stage, but they unfortunately couldn't be here. So please smile. Oh, just a second. And one for backup. OK. So a little bit about me. I started my journey as a Linux system administrator in ancient time of black and green consoles and terminals. The next step or evolution of that journey was, of course, moving into cloud. After caring for large cloud deployments, I started to care more and more about security, so I moved into security for a while, and realizing that security was really just a lot of paperwork and not, movie hacking. I moved back into Linux system administration, and then to something called DevOps, and as I had some experience with security, DevSecOps. As I'm passionate about new technologies and R&D, I joined TomTom 3 years ago, and I'm working there as senior application engineer and YAML programmer, leading secret management team. If you want to contact me after this presentation, these are my handles on LinkedIn and Twitter. If you're not familiar with TomTom, we are map makers. We are providing geolocation technology for drivers, car makers, enterprises, and developers. Our highly accurate maps, navigation software, real-time traffic information, and APIs enable smart mobility on a global scale, making the road safer, drive easier, and the air cleaner. So this is the agenda for this presentation. I will talk a little bit about secret management. Then I will show you HashiCorp Vault timeline in TomTom. I will show you how HashiCorp Vault was embraced in developer experience in TomTom. You will learn some of our use cases in Kubernetes, some extra tools we developed to help us with that experience, and then I will give you some takeaways at the end, if we still have time. So I was told that every good presentation starts with a story. So let's start with a story. This is my spider. It's a Brazilian black tarantula. As I was really afraid of spiders, I thought that getting one was a really good idea. So I got this spider, and I got a terrarium for it. At that point of my life, I was working as a Linux system administrator that was also in charge of security for the company. So I had access to company's keys, passwords, and I also needed to keep them safe. So I stored them on a USB flash drive for safekeeping. And thinking about the best place where to store that USB drive, I saw a plastic zip bag on my table. And you can probably see where this story is going. The original idea was pretty straightforward, hiding my USB drive within Spider's terrarium inside a zip bag. And that's also what I did. I managed to recover those keys a few times successfully. The main problem here is that every time I needed a password or any credential from that USB flash drive, I needed to open the terrarium, put my hand inside, fight my fear, fight the spider, recover the flash drive, put it in my laptop, extract the keys, and then do the whole process in reverse. And as someone who had trouble with passwords all my life, who had a lot of TXT files and notes and whatnot, I realized that this was really not an optimal solution for this problem. So there was a solution for managing secrets a long time ago. And of course, as many of you know it, it was called connection strings. The only place where you needed to keep your passwords, because you had one server, you had one database, you needed to connect it. Connection string was the only place when you needed to have your password. But as your team grew, you get more and more developers, you get more people, you needed to share those passwords. And what was the best way to share your passwords? Of course, email, as the most popular way of sharing passwords, being only shadowed now by Slack as the new primary medium. Back then, we also had these really, really cool password sharing platforms. They were working in offline mode and online mode. I'm, of course, talking about passwords.txt that were on some shared drive or in some version of online document management system. And, of course, we cannot forget about good old hard-coded passwords in Git repositories. Also, most of these passwords were, of course, used in all the environments that your company had. So, moving into future of the apps now, they are running in multiple instances of microservices, communicating with each other, communicating with redundant databases, various frontends, various backends. So the question that came naturally is how to really secure these credentials. So this is where the concept of secret management solutions comes into play. Secret management is, of course, used to manage and protect your secrets. And deploying your application without having hard-coded passwords for your infrastructure or the infrastructure, in this case, is really a necessity. There are also no more messy codes with various environment variables running around. And in case of TomTom, the requirements for secret management solution were pushed by developers and by the management at the same time, which is really, really strange. That also meant that the secret management solution needed to fulfill some of the requirements that were gathered. And the requirements were pretty straightforward. Auditors, the audit team in TomTom requested us to have a single source of truth with an audit log so that we could basically see who used the password, how, when, and we could have this whole trail of password usage in the whole company. Developers wanted to have programming access to the solution, so of course API interface is the main thing that they needed. From security team came another requirement, and that is for secrets to be transmitted securely and encrypted at rest. From our SRE team, we got a requirement to have a highly available solution running in multiple regions. So this is highly available solution running in multiple regions, and also to have configuration and infrastructure as a code. Multiple authentication methods were also required, so if one of them fails, that we still have some way to access our secret management solution. And of course, secret versioning, which is a lot of help if you have teams that change their passwords, but they do not change them in their CI/CD pipelines. So at one point, you need to recover the old one to help them with this. So out of all the different vendors that we tested at the time, we chose HashiCorp Vault as the primary one. And I will now quickly show you the implementation timeline of HashiCorp Vault in TomTom so that you can understand how this process looks in the enterprise. So this is our timeline. And if we go step by step, you'll see that timeline for HashiCorp Vault is really an interesting one. So the first ticket that we got about secret management solution goes way back into October of 2017. There was a need for a secret management solution, and HashiCorp Vault open source was recommended at that time. Only a year and a half later, which is really short time if you ever worked in the enterprise or a bank, we finally managed to do a POC of HashiCorp Vault running on a small virtual machine in our OpenStack platform. And a few members of one team were using this solution. In 2019, you remember it was year of Kubernetes. It was beeping enterprise IT as this new big thing. So naturally, our next proof of concept needed to be run on Kubernetes. At the same time, HashiCorp announced Helm chart for deploying Vault on Kubernetes. So we had another challenge, learning about all these new technologies and also trying to build a successful secret management platform. This POC ran Consul. It had open source edition of Vault, and it was running for some time. And after some general usage from a couple of teams, we decided to finally try enterprise features of Vault. So we ran 2 proof of concepts of Vault and running this one in the same time because there were still teams using it. So the first proof of concept of enterprise was in March of 2020 with emphasis on exploring different modules that HashiCorp Vault provided. As our trial license provided us access to all the modules, we went through them all and tried to find which modules fit us the best. Then the second proof of concept was tested, emphasizing on comparison of HashiCorp Vault Enterprise with similar secret management solutions. And naturally for us, 2 of the most promising features that we saw were ability for us to do our own disaster recovery and of course namespaces. So the next few months we're writing documentation, and more documentation. By documentation I don't mean Vault usage, but all the architectural and all the documentation that is needed to enroll solution in the enterprise. So where this solution is going to connect, who is going to use it, how, all the moving parts, basically everything. We also had reviews from our internal teams like SRE, Cloud Center of Excellence, and of course security. And after all of that, we were finally ready to go to the MVP phase, a minimum viable product, with HashiCorp Vault enterprise instance that had only a couple of users. But those couple of users show really as power users. And at the time, they provided much needed feedback for us to finally move to LA, which is limited availability. And HashiCorp Vault was then introduced to a limited number of teams that were using the most basic features of Vault. So just KV store and the namespaces. A few months after that, after more testing, more writing documentation, more feedback, more usage, HashiCorp Vault was finally signed as a developer productivity standard for secret management within TomTom. So as you can see, it really takes some time for a product to go from this introduction phase to being considered a company standard. And also one more thing, in April of this year, we replaced Consul with Reft to simplify our backup restoration process. So this was a complete timeline of Vault journey in TomTom. And as Vault was now introduced as a secret management solution, there were some expectations from this new tool. So in TomTom, we are trying to provide a great developer experience for all of our developers, which if you really think about it, it's just user experience if your users are developers. And as in every puzzle set, you get all these little pieces that you need to put together to get a bigger picture. And the same is in developer experience, where all of the tools that your company is using are just these little pieces that you need to put together. And as HashiCorp Vault is a pretty big piece of the developer environment, we wanted to, for our users to have a great experience interacting with this solution and using Vault as a secret management. One of the most essential things that we do in developer experience is onboarding and onboarding procedures for any solutions that we are using. And HashiCorp Vault is a tool that is basically designed with DevOps culture in mind. And all DevOps concepts are applied to Vault, like automation, CI/CD, infrastructure, configuration as a code, and many more. And we use all these concepts in our day-to-day work, from creating the initial Vault infrastructure to configuring Vault performance replication, disaster replication, or just onboarding new users. And the idea for this onboarding process was really simple. We wanted for our users to just provide us 2 pieces of information to onboard on Vault. And those 2 pieces are name of the new namespace that they want and the name of the Active Directory group. And with, they are using our self-service portal to enter those 2 pieces of information. And after that, after they click finish, they get an email with basically all the guidelines how to connect to their own namespace. What happens in the backend, pipelines are run, they're running Terraform. Terraform connects to Vault, configures new namespace, configures all the policies, and provides admin access to this new team. Also, when we were preparing Vault for all these new users, we encountered a couple of major challenges as well. And as you may know, driving the adaptation of the new service is never an easy task. If you ever played baseball in a cornfield, you will know that saying, if you build it, they will come, will not work in IT. Many users didn't know about Vault. We had really low initial onboarding for users. They didn't understand value of secret management and what it means. So at the beginning, we had this really low initial number of users. And to overcome that, we created these monthly stakeholder meetings with users our current users providing really interesting use cases that some teams implemented. We also showed them the new features in Vault that were out. We also tried to provide really good use cases that maybe they can use in the future. And this was really effective, as we immediately noticed a rise in users and teams. And after every iteration of the stakeholder meeting, we announced this on all relevant Slack channels, and we noticed that we are getting more and more users. Resistance to change was our second major challenge, because people in general don't like change. And introducing a new solution to developers where they need to rewrite part of their code is never a nice option. And in the absence of primary secret solution, at that point, developers use the third-party ones, they use the cloud-native ones, they write their own solutions, or they didn't use any solution at all. So to help them, we created this really detailed procedures for migration from their current solution to HashiCorp Vault. And not using best practices. Most users will automatically use all the default policies, default roles, and just keep on putting secrets in your namespace. And they will not use best practices because they don't even know how to do that. So to tackle that, we created something that is called onboarding call that we do now with every team requesting a new namespace. There we try to explain them how to use Vault in their own respected programming languages, and we tried to push the best practices on them before they start using this solution. And of course, once again, existing solutions, which was at the time a big challenge for us. At the end, we managed to convince most of the teams, but the main point here was to have a lot of discussions, a lot of meetings, and trying really to convince them why using the central solution that the whole company is using for secret management is the best way for them to use this secret management solution. One of the biggest challenges was also documentation, because this is by far the most requested thing that we get in our support channel. And we try to offload all the documentation to HashiCorp Vault official documentation, because that documentation is amazing. So we didn't want to copy-paste the same documentation around. So basically, most of our documentation is just frequently asked questions that we get in our Slack channel, and some really specific TomTom use cases. Because we realized that most of the developers don't really read the documentation until they stumble on a problem. So our onboarding call that I already mentioned proved like a really good thing to solve this. When they are requesting namespace, they will get all these examples in their respective programming languages. Also, with the documentation, we added a small Terraform sample for teams so that they can use this Terraform to configure and manage their namespace. And Kubernetes. As in any other enterprise, Kubernetes is used on a large scale in TomTom. As most of you know, secrets in Kubernetes are encoded. They are not encrypted. We needed a solution to move from these static Kubernetes secrets to something more secure. And that, of course, is the integration with HashiCorp Vault. So one of the things that we really wanted to do was to enroll these Kubernetes clusters that were Vault ready. And by Vault ready, I mean that when you enroll the clusters, at the end, you can consume secrets from Vault. So to leverage this, we created a workflow to experience a part of our GitOps culture. And everything starts in a GitHub repo. where our Kubernetes reference architecture template resides. Azure DevOps pipeline is used then to deploy resources with Terraform from that GitHub repo into Azure Cloud. Terraform then deploys Kubernetes. It deploys and configures container storage interface provider or Vault agent, depends on what you choose. Terraform then gets outputs from Kubernetes, JWT token, host, and certificate. It then uses that output to configure the Kubernetes auth method on Vault and in the respective namespace. And when all pipelines are completed, that Kubernetes cluster is ready to consume secrets, and our application is ready to use them. Everything is done with one workflow from initial Kubernetes deployment to Vault configuration and secret ingestion. Also, some things that we found out while doing all of this, and they are mostly around monitoring. So yesterday, you had the opportunity to hear how Prometheus is a really great tool to monitor things. And we use the Prometheus Alert Manager and Grafana stack to monitor most of our tools and services. And one of the great things is that Vault provides telemetry that Prometheus can consume. So we monitor a lot of Vault metrics in Prometheus, but the ones that we would recommend for you to really pay attention to are basically the number of inactive or unused tokens, which are really good indicator that someone misconfigured something. So we had a couple of cases when we had tens of thousands of inactive tokens that were later traced to an auth method that was not configured properly. Duration of requests. This metric is used so you can track how your users are experiencing Vault and how fast Vault is for them. Also, rise in duration of requests can indicate problems with networking, problems with your backend, or some other stuff. Seal status. You heard it yesterday. This is no-brainer. First alert that you need to create for Vault should be the seal status. If your Vault is sealed, then it's unusable. And of course, resource quota violations. This metric is really powerful, and we are using it because we are providing namespaces for other users, so we can also see misconfigurations or abuses from teams that are trying to do something that they shouldn't do. And here is the thing that I'm personally most proud of. So we created some tools to help users use Vault in TomTom. And one of the first tools we created for users is a simple policy generator. We wanted basically our users to have the best experience when creating policies and when learning how to create policies. It's a Python-based solution that generates HashiCorp Vault policies with required permissions that then developers can use for their own specific policies that they need to implement. Solution is basically you specify a path, you specify all the permissions, and policy in Terraform or HCL format is generated as an output of this solution. Also, solution can check if there are some bad practices in policies, like all default permissions, so using sudo and many more. Our second tool that we created answers the question, how can we track the expiration of the secret in Vault? As any other company, we had some issues with secret expiry. We are using Azure. Azure has this service account called Service Principals. Service Principals have secrets. Secrets can expire. So we were also storing them in Vault. We also had some other secrets that had expiry. So we really needed one solution to tackle this secret expiry. And as I said, we are leveraging Prometheus on a large scale in our team. So basically what we did was pretty straightforward. We created Prometheus exporter for monitoring secret expiry. So how does it work? It uses, basically, it's a simple thing. It uses application role to go through configured secrets. It gets secret expiration from metadata, and then it provides this data for Prometheus to scrape. With this, we got an excellent way of getting notified when secrets need rotating or the secret is about to expire. And you can also create simple Grafana dashboards to track them all in one place. We have also open sourced this tool. So it's available to you on TomTom International Vault Assessment Prometheus Exporter GitHub repo. I will also show GitHub repo at the end. And while I was having this presentation, we enrolled version 1.0 today. And some takeaways at the end. Of course, secret management is a must for any company. If any of you works for a company that doesn't have any secrets, credentials, or certificates, I would really like to talk with you after this presentation, because that would be really interesting. Manage your expectations when you are enrolling your solutions, because users will need help. And you will need to provide some best practices for them to really embrace your solution. Also try to create tools to help users, to help them address all the issues that they are having. Try to be data-driven. So we are monitoring everything from user adaptation of our solution to most used engines, most used secrets, all the infrastructure that we have that is connected to Vault. Try to connect. This is more of, let's say, more of a global advice. So what we did at one point, we tried to find companies that were using Vault Enterprise as well. We tried to connect with them to see what are their problems, how did they build their own solution. You can always learn from other people's mistakes. And you can also find some good things from different companies about how the solution can be used and enrolled on a totally different level that maybe you have. And of course, try our Vault Assessment Prometheus Exporter. If you find it interesting, please start it. And that's it. Thank you. Feel free to approach me after the presentation, and I would like to thank my Vault team, Eugene, David, Mateusz, and Michal, for getting me here. Thanks.